Okay, so really quickly now. So this 0, 1 is the first sequence of numbers. Generally, a parameter is a 4-digit number. So as an example here, 3401, 4 digits, but the first 2 digits on the left here, 34, that would be the first 2 digits that we generally use to scroll up and down. Okay. So this 0, 1 is the first 2 digits of this number here, 102, which represents RPM. This 104 represents current. This 103 represents hertz, which basically is where you choose what to view on the drive. So you press start, the motor starts to turn. It'll display, let's say, 500 RPM. You press the up arrow key. The corresponding current, you press the up arrow key, the corresponding frequency. Okay, these are just 3 examples right now, but you can program several dozen different types of parameters or variables to display within these 3 parameters, which we're going to cross-reference afterwards when we get to the 3400s. Okay, so we're going to start at 0, 1 and go all the way to 99. Okay, not every number in between, but quite a few of them. So this parameter 1001 is the most important one. It's probably the most intricate one where you have the most choices, okay, and important choices as well, because this is what decides how you're choosing to operate the motor via the drive. Okay, so how are you going to program it? How are you going to start it? Do you have a stop start? Do you have a forward, reverse, selector switch, push buttons? Okay, et cetera, et cetera, et cetera. So the first one we saw was 1001, selection 1. Selection 1 is right here. Okay, so if we go on the right here, selection 1, and if we read what it says is that you're going to have only one digital input, which is right here, which is 12. Digital input 1 is 12. And since there's, well, what I'm going to introduce now is, since here you see there's a P, right? P and P. What is P for? P is for pulsed. Okay. Also could stand for push buttons. There's no P here and there's no P here, which means that you're not using a push button. Hence, we have a selector switch. So the simplest way to control the drive would be to put a selector switch here. And when it's 0, it's basically stopped. If I activate the selector switch, digital input is 1 and it'll start. As it explains right here with selector, if you select a 1 in parameter 1001. If we select a 2 in 1001, that means what we want to do is what's explained in this paragraph here. And what it says in this paragraph here is that you're going to choose DI1, or you're going to wire up DI1 with a selector switch. And if the selector switch is open, then your input DI1 is a 0. And if it's a 0, it's stopped. If you close it, then there's current flowing to DI1. Then it's a logical 1. Logical 1, the motor starts. It gets a start signal. Now, what happens here, the main difference between choice 1 up here and choice 2 down here is the fact that here for choice 1, all we have is one input. It's just to stop and start. Here we're saying not only do we want stop and start, we want to be able to change directions. So if we do activate digital input 1, it'll start. If the selector switch wired to DI2 is open, then the input is a 0, it'll go forward. If I close this blue selector switch here wired to DI2, then you have current flowing to DI2, which means that it's a logical 1, and it'll change directions and go into reverse. Okay? Are we okay with this so far? We have 2 selections. They're the easiest ones, because the next ones after this are going to be a little bit more complicated because we're going to have push buttons. All right. So the next selection, let me just clean this up a little bit here. Let me just erase this. Okay. So the next selection down is going to be selection 3 right here. And look, this is important. Di1P and Di2P. Now this P stands for pulse. But for you to remember it, it can also stand for push button, okay? So if there's a P, you're going to wire up a push button. If there's no P, it's not a push button. Because what a push button is what? What kind of contact is a push button? Is it momentary or maintained?
Momentary.
Momentary. A push button is momentary. That's why it's called pulse. You hit it, it changes the state. When you let go, it goes back to the initial state. Whereas a selector, which is what we're using here, and it could be a contact from a PLC, okay? But we'll make it simple. With a contact like this, it's maintained with a selector switch. So here, we'll start this one off. Our next scenario here will be if we select 3. So this is what I want you to write. Right here. And I'm going to borrow this. Now, how would we wire the drive if this is this scenario we wanted? What does all this say? I know it looks like there's a lot of reading there, but really there isn't. You just take it step by step. It's not too bad. It says here, pulse start, first of all, right? Because it's a P. As soon as it says pulse start, what are we using? We're using a push button. So pulse start through digital input DI1. This symbol here is 0 to 1 with a little arrow. That is a rising edge. Rising edge means that it's a normally open push button like this one here. And when you press it, it closes 0 to 1. So it says to wire that up. Where does it say to wire it up? To DI1. So what I'm going to do is I'm going to take 24 volts here from 9. Remember, 9 is our positive, 10 is our negative. Our 11 is our common. We need a jumper between our negative and our common because of the internal relay. And then we have a start push button. Why am I selecting a start push button here on 12? Who can tell me? Why a start on digital input 1? Because a start is a normally open push button, which is a 0, right? Because there's no current going through it. When you press it, there is current going into the input, so it becomes a 1. So 0 to 1, a pulse start in digital input 1. So pulse start in digital input 1 means that you're going to use a start push button. So let me identify it as a start. The start. So the start push button. So if we have a start push button, we also want a stop push button. So what we're going to do is we're going to wire up a stop. And I mean, I already know that the stop has got to go to terminal 13, and it's a stop is normally closed, and terminal 13 is DI2. Okay. But how do I know that the stop has to go to DI2? Well, you keep on reading. Look, it says pulse stop through digital input DI2. And then it doesn't say 0 to 1, it says 1 to 0. What does 1 to 0 say? It means that if something is a 1, it means it's normally closed because there's current going through. And then if you press it, it becomes a 0. So this symbol right here is a falling edge. And how do you get a falling edge? With a normally closed push button. Why? Because you have a 1 all the time because there's current going through. And then when you press it, you break the contact and you get a 0. So 1 to 0 is a falling edge. So I'm going to write that down here as well. Here we have a rising edge with the push button. and here we have a falling edge. What was this called before, Jonathan Dedes? When I explain this? When we're
D2.
well, yeah, but what are we simulating here? This is not the way we used to hardwire stops and starts, right?
No.
But it's going to simulate something. What kind of control was it? What was it called?
I don't know. I
It
just
was
know
also one of the macros. And it starts with the number 3.
the macro control.
This simulates a 3-wire control. This 3-wire is going to be huge for you to remember. 3-wire control means what? It means you have a stop, start, maintain. We're not maintaining here like we were before. Okay? I'm going to draw it out so you can picture it. You have a stop, you have a start, and you have a contactor, let's say, and you have a maintain. So what we're doing with the drive is we want the drive to work exactly like this did, where we're pulsing the start to start and pulsing the stop to stop. Well, this simulates that exactly, okay, without needing a maintain contact. It's done internally. The only thing it says here, the part that we didn't read, and it's fairly important, is this part right here where it says, in order to start the drive, digital input DI2 must be activated prior to the pulse fed to DI1. What does that mean? Well, look, before, when we were using this hardwired 3-wire system, in order for us to press start and the contactor be energized, well, guess what? The stop was already energized, right? This has got to be normally closed before you press start. Well, all this means, what I highlighted here, in order to start the drive, digital input DI2, which is the stop, must be activated prior to activating DI1, which is basically pressing start. So in order for this to work here, this has to be closed before this can accept. In other words, if you hold the stop, it's not going to work. Well, how did this work? If I press the stop here and I press start, would it work? No. So basically, it does the exact same function as this did before when we were hardwiring. Can we move on to the next one? Okay. And you know what I'm going to add here? I'm going to add a P. Okay. This is a P. Pulsed. Okay, so we've done 1, we've done 2, and we've done 3. We selected this one here, done. Select this one here, done. Select this one. So what is this? If I program in parameter 1001, if I program a 4, what does it do? And how do I wire it? So I want you to come up with this on your own. I'm going to correct it, but I want you to try to come up with it. So make sure you read it. It's direct what you have to do. Did anyone get it so far? Or think you know? Yeah, Alex, what would you? What is it used for?
It's the same thing, but it has a selector for forward, reverse.
Exactly.
Selector switch.
So if you read it, the first couple of lines are basically a carbon copy of the previous one. DI1, DI2, both with P's, which means that you're going to wire up DI1, DI2, terminals 12 and 13, with push buttons. Now you have to read to find out which push button goes where. Where do you wire the start? Where do you wire the stop? And then there's a bit more information because you want to be able to change directions. But if you notice, the third input here does not have EP, which means you're going to change direction with a selector switch. So have a look at what I have and see if you've got the same thing, or at least if you were thinking the same thing. Start and stop the same as before. They both had P's. So you're starting and stopping, starting with DI digital input 1. Okay, normally open contact, you press start, it starts. When you press stop, falling edge in digital input 2 stops. And then as it states in the manual for 3, it states at the bottom here, direction through digital input DI3. When it's 0, it's forward. So if I press start and digital input 3, the selector is not activated, it'll go forward by default. But if I close the contact going into DI3, the selector switch, it'll change directions. Okay, and you don't have to press stop in order to change directions. Okay, but you cannot change directions if you don't press start. So basically, if you press stop, it doesn't matter what position you put the selector switch in, it will not start. It will not change directions. You have to press start first. Kind of like the project that you did, if you remember, right? You had to press start and then you select forward and reverse. Well, basically, this is what you did in the project using a lot fewer components. If you remember how long it took you to wire that, okay, there's no flashing light here, but still, stop, stop, selector. A lot easier than what we went through, okay? So the drive, although it's a steep learning curve to find out exactly how to configure and wire according to what we want, once you understand it, it's so much easier to do exactly the same thing as what we did before, but hardwired. Are there any questions on this one here? We've got one left. Actually, we've got 2 left, but the last one probably your favorite. There's not much to do. But if we increment the choice by 1, so in other words, we're going to select 5. How do you wire this one here? You're going to have to follow 5 here. By the way, does anyone see this here? Did anyone see? No one said a thing here. There's another parameter here, 1003. What is 1003? Look, let's go to the next page here. Look at the next parameter here, 1003. What does it say? Well, it says that if I select 1, you can only go forward. If I select 2, you can only go reverse. But if I want to go forward and reversed, I have to select request. And that would be choice 3. So here, okay, 1003. 1 is forward only. 2 is reverse only. If I have a switch going into DI3, a selector switch, it means I want to go forward and reverse. So if I don't program it for 3, it's going to give me an error. It's going to tell you, well, you're programming not to go reverse, but you're telling me to go to reverse, right? So you have to make sure that if you have a reverse selector switch, or we'll see another way to get reverse as well, you have to also program 1003. Okay, so 1001, 1003 go hand in hand. So remember that when you're figuring out how to wire this one here, which is selection 5, you also have to program 1003. How you doing, Matthew?
Doing good.
Are you getting it?
Yeah, somewhat. I take a little more practice.
Do you know how to wire this one here up?
I have an idea.
What's your idea?
It's like the last one that we did, but now you just add a push button instead of the selector switch for input 3.
Okay, and did you read to get the details? Whoops, wow. So a little too far. Did you actually read it to see if that's exactly what you have to do?
Yeah. I don't know if it's exactly what I have to do, but I read it.
You did read it.
Yeah. Understanding
Bruce,
is another
Bruce,
thing.
did you read it?
Reading.
Reading. Kevin, did you read it? Diego? And what does it say?
I read it.
Did you understand it though?
Yeah, I think so.
Okay, so where do you wire DI1? What do you wire into DI1? Are you saying something, Kevin?
Like a start for DI1?
It's not a start. It's not just a start, I should say.
Oh, it's
What
the
is it?
direction button, is that it?
Yeah, look,
DRI?
it's a forward. It's a start forward. Okay? We didn't have start forward before. We just had a start. Now we have a start forward. Now this is where Matthew probably made a mistake. Is if you keep on reading, what about reverse? Where does reverse get wired into? Because if I remember correctly, Matthew said that it's basically identical to the previous one, but you're changing the selector switch, but it's not. What's the difference between selection 4 and 5? You're right, you have 3 push buttons, whereas here you have 2. Here you got 2 push buttons. Down here you're going to have 3. But is the orientation the same?
No.
No, it's not. If you read it, it says that, yes, it's true that start forward is DI1, but stop is no longer on DI2. Here, I want to bring your attention to stop. Stop is on DI2. But if you read this, it says pulse start reverse is on DI2. That means that you have a normally open push button because it goes from 0 to 1. And it's a start reverse. Basically, it's a reverse push button. So it's got to be normally open. So your stop is now normally closed. If you keep reading, it says pulse stop through digital input DI3, 1 to 0. That's your stop. Okay? So you got to read it properly because if you don't wire it according to what it says here, it's not going to work. And this is what you get. And don't forget about programming 1003. So we have a forward followed by reverse and then followed by a stop. So you got rising edge on DI1 with the forward push button, falling edge on rising edge again, sorry, on DI2 with the reverse push button. And your stop has to be wired to DI3. And there's your falling edge. So as we go forward here, are you making the connections? Are you understanding a bit better, like what's involved to actually wire it and program it? Good. Diego's gonna like number 8. Did you read it yet, Diego?
No, but I got this one right. I'll start reading it.
Good.
Which one? Number 8.
Number 8. Excuse me. This is number 8. Right here. Beautiful. You have to wire anything? No. Let me just center this properly. So if you look at the keypad, you have a start and a stop. That's it. How do you change directions? See if any of you remember. With this guy right here. Okay. This basically has an arrow going back and forth. So it's not a reverse push button per se, but it's to change directions. So selection 8 is basically using the keypad as a stop start. So stop start right here. And if you need to change directions, you press this button right here. So there's no control wiring if you're using the keypad. So this is the keypad. Selection 8 means that you're controlling it directly from here. No need to wire an external or remote stop start. So this is, needless to say, the first one we're going to start with on the very first lab. Right there. Okay, selection 8. There are other more complicated ones, but we're going to get there eventually. Because you can get like delay starts and all kinds of other goodies. Connor.
Yes, sir.
How you doing?
I'm coming along.
Okay, get involved, Connor. It's a lot easier to explain or to understand and retain information if you participate. Are you understanding so far?
I basically just started grasping with the one that we just did.
Okay. You have any questions?
No, I'm working on the next one.
There is no next one.
Okay.
There's no, by next one, did you mean the next selection 1001? If so, that's it. 8 is the last one. So we have selection 1, 2, 3, 4, 5, and 8, and that's it. All right, so for 1003, okay, so basically on the right-hand side, we just finished with 1001, okay? We've covered all the ones we're gonna cover in this class, and we're gonna go to 1003. We talked about 1003 already because we kind of integrated it into our reverse push buttons, okay? So I'm just gonna write one more thing, have it kind of on its own. So I'm gonna add this. By the way, there's a reason why I'm not putting page numbers here. Parameters are in numerical order. So if you open up the manual and you go to and you see you're in 1010, basically you're at the beginning and everything else is in numerical order. So for 1003, this is what I want you to write. I know that you've already written this like up here. Okay. But this was basically to cross-reference. Now here we've incremented from 1001 to 1003. Okay, and that's going to happen quite a bit because certain parameters are going to be working together. Okay, 1003. Those are your choices. You can program a 1, a 2, and a 3 in 1003. The next one we're going to do is your jog, which is 1010. You guys remember what jog was used for? What is jog used for?
You mean like just like a forward or reverse, like push button? Is that what you mean?
It's a, well, jog is basically when you don't want to maintain. It's
Yeah,
also called
I
like-
couldn't pick out the word, so
Yeah, it's like inching the machine. So if you press jog, the motor will run, but as soon as you release it, it'll basically stop. Okay. What I want to tie in here as well is the basics of the drive in a short video that I made for you. Okay. Right here. So let me integrate this so that you know when I say you're pressing this, that, and the other, what it actually means. Okay, so have a listen, please, Jonathan Deeds. All right. Let me know if you can hear it. Hopefully you can.
To enter parameter mode,
Can you hear it?
I press enter. I have three choices: reference, to change the speed; copy, which we won't be using, it's to upload and download information; and we have PAR, which is parameters. If I press
So basically what we're talking about now with the 1001, 1003 is parameters. So watch what happens as soon as I press enter here.
enter here, these are all the
Does this look familiar? 01. We talked about that first. Those are basically the values that you program in the 3400s to decide what you want to see. What do you want to see? Volts, amps, hertz, RPM.
parameter numbers.
As I press the up arrow key, it's incrementing the count. Okay. And then when I press enter, it's going to turn into a 4-digit number. These are the first two, the most significant on the left. Okay. So as for an example, if you want to get from 04 to well, I shouldn't say 04, let's say 401 to 5,000, you're not going to press it like 4,600 times, right? What you're going to do is you're going to go down to the 2-digit number and increment the 4 and press it all the way to 50, which also is quite a bit, but it's a lot less than pressing it thousands of times. Okay, I'm exaggerating a little bit, but so have a look, see what happens.
One of the first ones we're going to discuss is 1001. So to get to our parameter number as quickly as possible is only 2 digits here, but if I press the enter, it'll display 4. So right now in parameter 1001, if I press enter quickly, it'll give me what the value is.
There was an 8 there. What's 8 for? It was programmed for 8.
Keypad.
Keypad. Okay. So when I press the number, it displays it. If I want to change it, I have to press and hold or double tap. Then I can change it to any of the choices we already discussed. Choice 1, 2, 3, 4, 5. Okay.
As we'll see, this value here, 8, is keypad or keypad control. If I press escape, it's back to 10. So I can increase quickly and go to, as an example, 14, press enter, 1401. Press enter again, it shows me the value in 1401, which is relay output, 3. If I want to change this 3, I would press and hold the enter, and then you see it flashing, and now I can change the actual value. To enter parameter mode, I press enter.
All right, let me just click on this one here. Okay, just to give you a better idea of, actually, no, this is not the one I want. I'm going to go to a more
So this is the drive.
basic one.
You'll see on the screen here, it says it's going 0.
Constant speeds, drive basics.
To enter parameter mode.
Okay. So have a look at this one here.
0 RPM. The motor is not actually turning. I have to.
So this is the first time you're actually going to
press
hear
start.
the
In this
motor
case
turn.
here,
When the motor is actually turning with the drive, it's going to make a bit of a screeching noise, unlike when you did a white delta or when you did the regular a regular lab when you're starting. Okay. So have a look. This is basically basic control using the keypad, using the start and stop.
I'm going to be in local mode. In local mode, if I press start,
You hear that noise?
so the motor is starting. You can hear that noise. That's the noise the motor makes when it's being controlled by a drive. And it's displaying the
Look, display. We talked about display, right? Well, it's displaying the RPM. What else can I display? Volts, hertz, torque. Diego, you listening?
actual speed. There's a potentiometer here. As I vary the potentiometer.
So that's where the pot is. Unknowingly, actually, for you to use the actual pot here, you can't be in local mode. The 1001 is on 8, which means local keypad. But to get the speed reference from something that's not built into here, you actually have to change the speed using the up-down arrow keys. If you're in remote, you use the pot to change the speed. If you're in local, you use the up-down arrow keys. And this is what I'm going to show you now to change the speed.
I can lower or higher the speed. Well, actually, no. That's actually going to be on remote because it's not locally here. I can actually change the speed here right now. If I go to reference, press enter, I can lower the speed here.
So the speed is actually in hertz here. Remember, it's a variable frequency drive. So now it's outputting 42 hertz. There is an equivalent RPM that was being displayed before. So now I'm going to use the up-down arrow keys here to increment the speed. Okay, because I'm in local mode, it uses the local up and down arrow key to change the speed. If I hit this button here, which says local remote, it's going to say remote, and then I can change the speed with the potentiometer that's here. Okay.
You can hear it slowing down. If I click on the local remote button here, now I can use the actual pot to lower.
And you can hear the noise.
So since
going up and down.
I'm controlling it with the keypad here, I can just press this stop here. I can also press this guy here. This guy here is reverse. So as you'll see, it's going to slow down. And it's going to go into reverse.
So you see that negative? So now it's going into reverse. Okay, that's because it's displaying percentage torque.
REV.
So now it's accelerating in reverse.
And stop.
Okay, so I want to give you an idea of the drive push buttons and what they did, so that the rest of this is going to make a bit more sense. If you want, actually, I'll put this in the chat. All right, close that up. This one here is pretty cool too. This is a former student, Alain, and this lab here is doing is pretty complicated. It's actually simulating a 3-speed motor using selector switches. So it's a pretty good lab. I'll put this in the chat as well.
It's on. Hey guys, so what we're doing right now is we're programming the drive.
We're not actually going to listen to this one though.
3 separate speeds.
And I'm going to put this in the chat as well. Bruce has probably already seen it. Thanks, Bruce. All right. So
I have actually.
You have? Okay, so basically, the last thing I did in that video was change direction. So in order for me to be able to change direction, 1003 had to have been programmed to 3. Otherwise, it would not have changed direction. Okay. All right. So the next one is 1010 jog. So 1010 jog or jog select is right here. So if you look at, I'm going to just take these blue marks off. Here it says DI1, DI2, DI3, DI4, DI5. It's basically asking you, okay, well, you want to jog. Where will you wire up the jog? Well, say, for example, you've already got a stop and a start and a reverse. Okay, that means you're already using DI1, DI2, DI3. Well, you can't put jog on DI1, DI2, DI3. They're already being used by something. So what can you do? Can you put on DI4, DI5? Yes, that's what you want to be doing. Okay. So here, for this one here, I want you to draw the same thing as before, but we're going to add some numbers. We'll basically take this. Actually, let me just give you a bit more content here. This is what we're going to do. And I'm going to show you how to wire it in a sec. Okay. So I want you to write this down, and I'm going to explain what it means. So 1010 is for jog select. So the example I'm going to give you is I want to be able to stop and start, but I also want to jog. Okay. Remember, before, to do this, you needed a contactor, you needed a relay, you had to isolate. It was complicated. Okay. Well, not that complicated, but compared to what you have to do here, it was complicated. So in order to do this, what we're going to do now is we're going to wire up, like we did before. We're going to wire up the jog on a separate input. So I've wired up the start on DI1, just like many of the previous ones, the stop on DI2. I'm skipping DI3. The simple reason being I want to use DI3 for reverse if I need it. Okay, because it's the only way I can go reverse if I need it in the future, let's say. So I'm not going to use digital input 3. I'm going to wire up the jog and go to digital input 4. So where this starts getting a bit more complicated is now it involves 1001. Why 1001? Because you're stopping and starting with selection 3. And if you remember, selection 3 was basically using a start on DI1 and a stop on DI2. So in order for this to work, in order for me to have a jog, I have to go to 1001, program 3. Programming 3 means that I'm wiring stop and start exactly like it says so. And then I go to 1010 and I put in a 4. Why a 4? Well, I'm selecting a 4 because I want to use digital input 4, which is right here, digital input 4. You could go to DI3 or you can go to DI5. I'm choosing DI4. Okay? So I have to tell it where I'm wiring it and wire it there. So I'm telling it I'm wiring the jog, because 1010 is for jog. I'm wiring it to digital input 4. And therefore I wire it on DI4. Okay? There can't be a conflict here. You have to wire it in the same place where you're telling it you wired it. And then here I'm cross-referencing upcoming parameters, I should say, which are 1201, 2205, 2206, because for jog, you have other options that pop up. Okay. If you're going to jog, you may not want to go to the top speed. Yeah, you may want to, but in most cases, if you're jogging, well, with the drive especially, you can choose to jog at a lower speed. So let's say the speed of the motor, maximum speed is 1725, and you press start. When you jog, what I'm saying here is, well, I want to go to 500 RPM. So when I press jog, I activate the jog because digital input 4 is active. But these 3 here, when 1010 is active, it goes into 1208 to get the speed I should go to when jog is active. So I press jog, DI4 becomes a 1. It starts to jog at 500 RPM because I put a 500 in 1208, which is a constant speed. And then I have 2 other parameters, 2205, 2206, which we'll cross-reference afterwards, which is acceleration time and deceleration time. And what does that mean? It means when I press jog, I'm going to get to 500 RPM in 5 seconds. When I let go, it's going to come to a complete stop in 3 seconds. Okay? So not only am I including a jog now, but I'm also saying I want the jog to go a certain speed. And also, in addition to that, I want to include an acceleration time for my jog and a decel time for my jog as well. How are we doing? Understandable?
Can you explain reverse for reverse?
Reverse for reverse?
That's what you wrote there, yeah?
Well, it's reserved for reverse.
Oh, sorry. Okay.
So I'm I almost read it as reverse for reverse as well before. So basically, if you look at the previous one, okay, the previous two, DI3 is being used in conjunction with forward reverse. DI3 here is reverse. So parameter 1001 is being used to stop, start, and reverse using DI1, DI2, DI3. So I don't want there to be a conflict. So what I'm going to do is I'm going to skip DI3. I'm not going to bother. Because if ever I do want to put a reverse, it's going to be complicated. Okay? I'm going to have to go back and change a few things. Okay? Also, as students, by wiring it here, because we're going to be doing one lab and then another lab, and then you have to go back and change the parameter, there's going to be conflict. So what I'm saying is to avoid conflicts, do not wire it to DI3, just go to DI4. But you could just as easily wire it to DI5. So Bruce, if I want to wire the jog to DI5, how do I tell the drive that I've wired it to DI5? Right here. I go to 1010. Why? Because 1010 is jog select. You see it here?
Yeah.
And
Yeah.
1010 is jog select. 1010 is what I use to communicate with the drive and tell it that I wire it to a certain input. So if I want to wire it to DI5, I have to program 1010 for 5. If I want to wire it to DI4, I have to program 1010 for 4. If I want to wire it to DI3, I program it to 3. Program it and wire it to. So whatever you program, you have to wire. It has to correspond. Good?
Good.
All right. So you see how you have a 12 here? Right here, 12. Okay, so now we're gonna keep advancing numerically. We did 1001, we did 1003, we did 1010. This is for jog. Let's go to, we're gonna skip the 1100s. We're gonna go to 1200s. And 1200s are called constant speeds. And here we are, okay? 1201, constant speed. Now, what does that mean? It means that if I want an input when triggered to activate a certain speed where you cannot vary the speed, it'll go to that constant speed, this is where I do it. So the number is 1201. And here is an example. Let's say I choose DI3. It means that whenever something is wired to DI3 and DI3 is activated, it's going to go to a certain speed. But 1201 works in conjunction to 1202. The reason for that is 1201 is just to select which input activates a constant speed, but you're not telling it which speed to go. So 1202 will be used to enter the speed you want to go when 1201 is active. Okay. So the example I'm going to give you here, we're going to go back to something we did before and include a constant speed. Okay, there's quite a bit on this one here as well. So let me just include it right over here. All right, so this is, before you start writing it, understand it, okay? 1201 constant speed. So I want to activate a constant speed. But look, if this looks familiar, it's because we've done it already. This in 1001, when we program 1001 to 4, we have stop, start, and a direction. The direction was a selector switch. So look, we have a stop, start, stop, and forward reverse. So now I'm taking one step further. I'm saying that when I activate reverse, I want it to go to a certain speed. So I have to program 1001 for how I want to activate or how I want to stop, start, and direction. Okay, well, that basically corresponds to these three. Because I want to change direction, I have to go to 1003, select 3, so I can go both forward and reverse. I'm going to go 1201 because I want reverse, as it states here, to go to 1000 RPM. So when I go reverse, I want to go 1000. So when I activate reverse, which is in DI3, the third input, in 1201, which is constant speed, I'm going to select a 3. So basically, when input 3 is active, which is when I activate the reverse, I'm also activating a constant speed, and that constant speed is stored in 1202. So two things happen when I activate reverse. I activate digital input 3, which activates reverse, right here, reverse. But I also activate a constant speed, and that constant speed is 1000 RPM. Okay. Understandable? I mean, it's not simple, but it's understandable until you try it yourself for the first time. No, actually, when you try it yourself, after you've done the lab and I've explained it, and you'll see, you'll make even more sense of it. But right now, it's kind of like getting desensitized to all these numbers. Okay? So I'll give you a few minutes to write all this down. But write it down. I hope everyone's writing this down.
I have a question.
I know Matthew isn't, but yeah, go ahead. Not sure if was that Alex? Did you mute yourself or?
Yeah. How does the drive know the RPM?
You're putting it in 1202, this 1000. So here I gave you an example. I said, example, you want to stop, start, and use a reverse selector. And when you do activate the reverse, you want it to go 1000. So what you're going to do as the user is you're going to go into 1201 input 3, because that's where your reverse is. But whenever 3 is activated, the drive will then search in 1202 for the speed that you want to go, and it finds it here. This is what you're inputting. You're going to program 1000 and 1202. You understand that, Alex?
How does it actually know what the
How does it know what the speed is?
Yeah, because it depends on the number of folds of the motor.
Oh, that's a good question, actually. You have to configure the actual drive and input all that. So at the very beginning, the first lab you're going to be doing, and we'll see it tonight. Well, if we get that far tonight, we're going to go to the 9900s, 9905, 9906, 9907. We have to input the nominal amps, nominal volts, nominal speed, frequency, all that. That's how it knows. And also, every now and again, it does a self-diagnostics, and it actually magnetizes the motor. You're going to see a number 2025 appear, which is called first start, and it actually does a diagnostics itself. So yeah, it needs to know that. You're absolutely right. Matthew?
Yeah.
How you doing?
I'm doing good. How are you doing?
I'm doing okay. Christopher?
Yep, I'm still copying.
Okay. Are you understanding?
Yeah, so.
Yeah. It's a lot. It's a lot of numbers. Just try
Definitely
to
is.
understand what I'm saying, and then we're going to put it into practice to fully understand it. But have an idea. There's a number. What does that number do? What are the choices? Basically, that's the goal here tonight. So Alex is here. Bruce. Connor still hanging in there.
Yeah, still just copying the notes.
Giuseppe, how are you?
Doing my best.
You have any questions?
No, I'm just trying to figure this out slowly.
Are you writing this down?
Yeah, I am.
Because otherwise it'll be a steep hill. Those first labs.
No, everything's been written down.
Okay, good. Ditas?
Yeah. And so from what I'm understanding is that you do the code and then it changes the properties of the function on 12, 13, 14.
It changes
For the
the
numbers.
function. Yeah,
Yeah.
it changes the function, and you basically have to respect the wiring so that it works according to what you selected. Yeah.
Okay.
Kevin, have you got any questions? Or is everything so-so? Good? Doing well?
Yeah, it usually makes like it clicks better once I have it all like in front of me.
Well, that's for sure. That's for sure. But
Mhm.
can you imagine being in front of a drive right now, and all we know is four parameters? So I'm going to kind of like plant a seed or plant seeds of what all these parameters do, and eventually you're going to get to play with the drive to see what they actually do live. Matthew says okay. Min, are you doing okay?
Yes, it's okay.
Christopher, are you done?
These numbers from 9 to 14, are those just like your terminals or something on the drive?
Yeah, exactly. This 9, 10, 11, 12, 13, 14. These are the terminals you're going to be wiring on the actual ABB backplate.
Okay. Yeah, I can sort of see that.
Okay, so the 1200s can do a lot more than just this. Also see when we'll get into the more advanced labs. If you look at it, what does this look like here on the right-hand side? This and this. Doesn't it look like logic circuits all over again? I'm telling you, logic circuits is more important than you think. So remember, when you have 2 bits, you have 4 different combinations, right? When you have 3 bits, you have 8 different combinations. Well, knowing what we know in logic circuits combined with what we're going to learn about the drive, we can select many different speeds if we choose to. Okay. So we're going to do one lab. We're going to fiddle with this a little bit, but it's going to be like a more advanced, not super advanced, but a little easier than what I just showed you there. So I'm going to continue until we get to 14. More specifically, 1401 relay output. I showed you the relay output before. I kind of explained it when I was showing you the 3-wire macros, or actually right before that. We have a relay, but it's not a regular relay that we're going to have to like press a button, activate the coil. Okay, we have no access to the coil. There is no, well, there is a coil, but the coil is going to activate or change the state of the contacts only when the condition that we've programmed is met, such as jog, Okay, so if I go to 1401 and I select jog, well, when I press jog, the contact will change state. So the main ones we're going to look at here, if you look on the right-hand side, is run, started, at set point, and jog, which is selection 52 right down here, a couple of pages down, 52. So we're going to write those three selections down. Okay, so you know them, because I'm not going to have you look through the whole manual when you're doing this, because there's a lot. Okay, this right I'm trying to do right now is just basically make you focus on, you know, not just simple labs. They're going to be pretty elaborate. We're going to be looking at many different situations and scenarios, but the drive can do, like, it's designed for so many different applications. We're just going to basically apply it to things we've already done before, but hardwired, and then a few extra ones. So relay output. This is what I want you to write down. Is everyone done copying?
I just need 20 more seconds.
Okay, just the writing at the bottom there?
Just at the bottom.
Okay. I'll go back in a sec here. There you go.
Could you scroll a bit higher, please? Right there's perfect.
Okay, so look, I'm going to paste this part right over here. So if you did finish, you're going to move on to 1401 and start writing this down, relay output. And like I said, we have 4 main choices. Choice 2 means run. Choice 7 means started. 14 at set point, 52 jog active. Now, what does that mean? Well, as soon as I press start, if the motor is running, the relay will change state. What that means is, have a look at what I drew here. Before you start writing down, have a look at my explanation, please. Let's say this 17, 18, 19, this is the drive. Okay, this is the drive relay. I have 17, which is a common. This here, 18, is normally closed. You see the contact is being made right over here. This 19 is normally open. So what's changing here is it's going from normally closed to normally open. Okay, so we're swinging this contact like this. So normally, if I were to have a line coming in here and a neutral hooked up to my light, as soon as I power up, my green light will be on. What I'm going to add here is a red light that just disappeared. Okay, a red light going to 19. Okay, so if I program A2 right here in 1401, it means that as soon as I press start and the motor starts to turn, this contact here will change state. So it's going to go from a green light being on to a red light being on. If I select 14, 14 means at set point. So Jonathan, if I take the potentiometer and I set it to 800 RPM and I press start, when it reaches the set point, this contact will change state. So at 800 RPM, it'll go from the green light being on to the red light being on. Okay? And Jonathan, you're not fooling anyone there. Pay attention to what I'm saying, please. Go, write it down, please.
Could you scroll up?
How about I make this a little bit smaller? That's small enough? Or do you have to go higher?
I just need the one line.
That one?
D2, yeah, okay.
Okay.
You only have one normally closed, one normally open.
That's it, yeah. We do have another, if you remember PNP, NPN, transistor switching. There is an NPN, PNP switch or contact as well, but this one here is an actual physical on-off contact, yes. We only have one. You guys need a bit more time?
I do.
The difference between
I need a little bit
between
more.
2 and 7.
Okay, Alex has a really good question. Okay, and I didn't bring it out earlier because if I give you too many details, it'll probably just be forgotten. But I'll explain since you asked me the question. So listen to the answer, please. 2 and 7 look very similar, and they are. Run means that when the motor is turning. But remember, with a drive, you also have a deceleration time. So if I press stop and I have a 10-second deceleration time, the motor is still running. So the red light here will stay on up until the motor comes to a complete stop, and then it's going to revert back to green. 7 is started. So when it starts, it's the same thing. But the only thing is here, what I'm saying here is as soon as you press stop, if you program 7, the red light will come back on. The green light, sorry, will come back on. So the difference is only when you stop. If you program 2, it's only going to go back to its initial state when the motor comes to a full stop. Whereas with 7, it'll go back to its initial state as soon as you press stop, no matter what the deceleration time is.
Seventeen is your actual line.
Say that again? 17 is the line, yes.
That's
Yeah. Okay, so if you've noticed on the right-hand side, I'm on 20. Right underneath 20, I've got 2001, 2002 for minimum and maximum speed. Christopher, are you good to go?
Yep, I got everything noted.
Okay. Everyone else, good? All right, so what is 2001, 2002? What is min speed, max speed? I think it's self-explanatory, okay? Why would you want a min speed? Why would you want a min speed? Why would you want a max speed? Well, you don't always want to go either or be stopped or go to maximum speeds. Maximum speed actually maybe is a bit more, a little easier to understand because we've already talked about the like ventilation systems and stuff like that. So actually, what about a conveyor system too? Like you may have a conveyor system on a drive, and if it's a bottle filling station, you don't want that motor to go like to maximum speed, right? So you can set a maximum. So even though the maximum is 1725 for the motor, you can set a maximum of whatever, like 400 RPM, as an example, 1000 RPM, okay? And so even if you crank, you use a potentiometer, you crank it all the way, it's not going to go more than what you set the maximum to. Minimum, well, you press start, and with the drive, if you actually set the minimum to 0 and the potentiometer is at 0, it's not really ideal for the drive. It could get damaged, but I'll give you a better example. If you have a totally enclosed fan-cooled motor, TEFC, right? So it's cooled with a fan. Well, if a motor is cooled with a fan, it means that the faster that motor turns, the more it cools off. Okay, and this is a problem I had at one point. If you set the minimum too low, well, the fan is not cooling itself off enough, and the fan's gonna, not the fan, sorry, but the motor's gonna overheat. Okay, so I'm just giving you some examples of where you would set it. So it could be that maybe you might want to set the minimum to 400 RPM, maximum to 1005. Okay, it's up to the user. You want to go 0 to 60 or 0 to 1725, I should say, instead of 0 to 60 hertz, which means the same thing. Go right ahead, but you can set the min and max speed. Now, remember when I told you that the speed of the RPM depends on the frequency, right? How do we change the speed of an AC motor? We change the frequency. Well, the drive gives us two ways to enter the speed. We can enter the speed in, as we see here, RPM, speed in RPM, or the equivalent in hertz. So we've got parameter 2001, 2002, and then we have 2007 and 2008, where you can enter the same information, but you're going to have to convert into hertz. Okay, so 0 to 60 hertz will be the same thing as inputting 0 to 1750 or 1800 hertz. Okay, so what if I said 30 hertz? Well, 30 hertz would be half the speed of the motor, the nameplate rating of the motor, so around 800 something. Okay, so for this one, what I've got for you is what I just finished saying, but in addition to that, a bit more information, because we have to go to, I'm going to introduce another parameter that's going to be needed for us to decide which one we're using. So we're basically telling the drive in parameter 9904, go look at 2001, 2002 for max and min speed, or go look in 2007, 2008 for max and min hertz, which means at the end of the day, the same thing. So let me explain what I've written here. 2001, 2002 is minimum maximum speed in RPM. Here I have an example of 150 RPM, 1500 RPM. But I can also enter in min and max frequency. Okay. Why do I have this here? Because I actually, I have to go to 9904 to tell it to either take the value in RPM. So if I go to 9904 and select a 1, it'll be looking in 2001, 2002 for the min and max. If I go to 9904 and select a 3, 3 represents hertz, it's going to go to 2007, 2008 for the min and max. Okay, so you're selecting one of two things. It's either speed or frequency. At the end of the day, it means the same thing, but I've got to go to 9904 to tell the drive which set to use. If you want the 2001, 2002, you go to 9904, you select the 1. If you want to enter the min and max frequency, or you want to enter speeds and frequency, you go to 9904 and you select 3. And what I've written here after that is just to show you that the relationship between the RPM and the frequency. So it's directly proportional, okay? Like I showed you earlier on as well. So 0 hertz is 0 RPM, 60 hertz is whatever the nameplate rating is, 1750, 1775, 1800. There's barely going to be a slip on our motor because we don't have a load. Okay. And also, I've included a conversion. So the conversion here is basically, if you want to convert, in this case here, 150 hertz, what I've written down is that, well, 60 hertz is equal to 1750. Okay, maximum speed of the motor. If I want to convert 150 RPM into hertz, I put an X above the hertz, and I cross multiply, and I solve for X, and I'm going to get 5.14 hertz. Just missing a 6 here. Okay, so basically here, if I take it one step, this is basically what the question was. How do I convert 150 RPM into hertz? Well, 60 hertz is equal to 1750 RPM. I want to solve for 150. I put an X. I want to solve for X. So I have to get rid of the denominator, the 60. So I multiply both sides by 60. I end up with 150 times 60 over 1750, which gives me 5.14. So the answer is 150 RPM. Its equivalent is 5.14 hertz. And then I did the same thing here to convert 1,500. How do I get 1,500 and convert that into hertz? So here's the math right here. They're the same thing. I showed you in less steps though, but same thing. How was the brain agility? Can take some more. Yeah, Diego could. See what happens, guys, if you take a nap? and a shower.
I did it now. Just
So- Yeah, well, you wake up late now. You wake up at 5:30 instead of 3:30?
4:30.
4:30. So what I'm thinking of doing now, there's about an hour left. I'm not sure how much more of this you can take. I can continue if you want, or I have an exercise, a questionnaire that maybe you can start doing. Maybe that you find that a bit more relaxed to maybe summarize everything we've done so far. You may not be able to answer all the questions because it does go, I mean, we're at 2008 and we have to go all the way to 9910. So that's not to say that we actually have 7,900 more to go. We're not doing that many. We just have 6,000 to go. No, we just have about we did about like 1/100. Maybe I should stop joking, eh? We did. I don't. How many did we do so far?
That's
If we
about
count-
half. No,
We have to cover about 40. In all honesty, about 40. So I think we've done about half. So these videos are going to get a bit long. So maybe it's a good idea that we do stop here. We'll stop the video. We can synthesize what we've done so far by answering those questions. And next class, we can finish off where you're a bit fresher at the very beginning. All right, so I'm gonna stop the video and have I guess a part 3 when we resume this.